Hi everyone. Today in the series of theory of computation lectures, in continuation to the previous video, we'll see one problem in the construction of finite automata. Okay. So today again we are going to discuss one problem. So we have to design a finite automata which accepts only even binary numbers over the input set sigma 0 comma 1. This is the problem statement. Okay, try to understand what they are asking. So we have to design a finite automata. The finite automata should accept only the even binary numbers. Okay, so you should know what is even binary numbers. So even binary numbers in the sense, what are all the numbers are called as even numbers. So we all know 0, 2, 4, 6, 8, it goes on, right? So how will you represent the 0 in the binary? You can make it as 0. What about 2? So the binary equivalent of 2 is 1, 0. It is 4. Binary equivalent of 4 is what? So you just remember this 8421 format. So what is the representation? 100. Okay, what is 6110? What is 8100? Okay, likewise it goes on. 10 means you will have 1010. Okay, so which means that they are asking to design a finite automata to accept only these strings. Okay, so now you identified what is the member of the language. Okay, this is the member of the language, right? So first of all, whenever you are given a problem statement, you try to identify the members of that particular problem statement. This is the language set. These are all the members, right? First member is 0, and then 1 0. You have 1 0 0, 1 1 0, and 1 0 0 0, 1 0 1 0. Likewise it goes on, right? Which means the language L is the infinite set. Okay, now you try to frame the automata. So in the previous class I have given some formula to check, to know how many number of states possible for an finite automata. So here you look for the minimum possible string, the length of the minimum possible string. So this is the minimum possible string in the set, right? So which means what is the length of minimum possible string? Minimum possible string, here in this set we have 0, the length is 1, right? So 1, right? The minimum possibility is 1. After 1 you are also having a string with the length 2, and also you are having the string with the length 3 as well as 4. It goes on. Okay, so which means that the length of the string are greater than or is equal to 1. Okay, this is the case. Okay, so for this kind of case, how will you determine the number of states? Which means whenever I say the length of this w is greater than or is equal to n, what will be the number of states required? That is n plus 1, right? For w is greater than n, then n plus 1 states will be there, right? This is what the formula in the previous lecture we have given, right? So n plus 1 means here 1 is in n, so which means 1 plus 1 you will get 2 states. Okay, so this is upon using this formula you are deciding the number of states here. So you have 2. Okay, so 2 states. So one will be here and another will be here. I'm just forming a skeleton here. So one by one, step by step, we are going to improve the structure, right? So first you are having this string, minimum length string is 0, right? So this is the starting state. Okay, now we don't know which one will be the final state, but here when you're looking into the string, you have to accept, finite automata should accept what? 0. If you are seeing 0, that the automata whichever you are designing should accept that 0, right? So if you are, we'll just name it, this is A, this is B, right? So now I am receiving 0. Okay, I am just reading 0 on the state capital A. Then what I am doing is that I am making this B as the final state, right? This one is satisfied, right? For this string, this automata is accepting 0, right? This automata is the for the string 0, to accept the string 0. Now you look for 1 0. Okay, so now you're starting from A, the state A. So you're looking the symbol 1, right? So when I'm seeing symbol 1, I cannot go to acceptance state. Okay, and one more thing is, here you just look each and every member of the language. You can notice that the string whichever is accepted by Finite Automata, that ends with 0. Okay, the string whichever is ending with 0 will be a even binary number. Okay, so now whenever I'm looking for 1, I cannot go to final state, but I only have 2 states here. So now when I'm seeing 1, what I make is that I'm making it as a self loop, right? So then I'm reading 1 0, so 1 0, it goes to acceptance state, final state. So this satisfied. Okay, these two strings are accepted by my design Finite Automata. In the next and then you just make a chance to next string. So you are reading 1 and then 0. Again you are having the symbol 0. Whenever I am seeing 0, I should be stay in the state, that is which is acceptance state, right? So I'm making this as a self loop. So this string also accepted 1 0 0, and then you are having one more string 1 1 0 1. You are reading 1 and then again you are getting 1 and then 0. This string also accepted by this automata. What about this? So again 1, you are reading 1, you are 0 is the first symbol is 1, you are just reading, you are staying in the same state. When you are seeing 0, you go to final state and then you are getting another 0. So you'll just stay in the same state, and after that you are getting another 0. You just make it a self loop, which means you will be staying in the same final state. So this string also accepted. What about this? You are reading the symbol 1, you are staying on state A, capital A, and then you are getting 0. So being on A, upon seeing 0, it moves to capital B, and then you are having 1. So whenever I'm seeing 1 on being on capital B, being on state capital B, I am looking for a symbol 1. So in that case, what I am doing is that I am just making a move to A, right? I cannot accept that string, right? So I'm just moving it to A, and then I'm reading 0. So when I'm being an A, I'm getting 0 and I'm just, the symbol is accepted. So which means 1 0 1 0 is accepted, right? This is also accepted. So likewise, the next string is, what is next string? 12 is the next string, right? So 10 12 means how will you make this? 12 8 plus 4 12, right? 110. So 110, just read the symbol here 110. You are reading symbol 1 on being A. You are staying in same state. Again you are reading symbol 1, staying in same state. You are reading 0, going to B, that is final state, and then after being in B, you are looking for the 0, last 0, staying in the same state. So which means this string is accepted. This is what the required Finite Automata for the given problem statement. Okay, so we will discuss construction of minimal DFA, those things in the upcoming lectures. Okay, I hope you understood what is the problem statement and how to find out the Finite Automata for this kind of problem. Okay, thank you.